All right, welcome back. This is going to be functional groups part 2. In this video, we're going to go over the ether functional group, the thiol functional group, the sulfide functional group, and the aromatic functional group. The ether functional group is basically an oxygen atom that's bonded to two R groups, or two carbons. A famous example is diethyl ether. This is an ethyl group. This is also an ethyl group. So you call it di, meaning two, diethyl ether. So notice we have a carbon here and a carbon here. And that right there tells us it's going to be an ether. Now, what is this huge molecule here? This is called helicondrin B. This is actually isolated from a sponge called helicondria. First, let's actually identify where the ether functional groups are. I'm not going to mention all of them, but we got one here. So this is an ether. We got one here. Let's look at here. We got one here, here. So this is a polyether. It's called a polyether because you have so many ether groups here. Many ether groups. Now guess what it does? I want to try to make these videos interesting. I just don't want to tell you the functional group and just go on. Because I want you to remember it. And I think if I tell you something interesting about it, you'll remember it more likely to remember. What does it do? Helicondrin B is used to treat cancer. It does. So it's actually found in the sponge, and when they isolated, they actually found it can be used to treat breast cancer. So this is why these functional groups are important. You can begin to understand what they do in certain molecules. So ethers are really important in medicine, especially for cancer treatment. Let's go to thiol. The thiol functional group, also known as a sulfur hydryl group, is basically a sulfur atom that's bonded with a hydrogen, so that's part of it, and the sulfur group is bonded to an R group, or whatever carbon molecule you want it to be. So it's basically an SH. So this is an example of a thiol group, basically our SH and a random carbon molecule. Now, why do you have a picture? This is supposed to be a skunk, if you couldn't tell. Yeah, I'm not an artist, but I try. Why do I have these three molecules here? Well, notice that we have a sulfur group here, or basically a thiol group, here, and then here. Well, sulfur is known to have a really distinct smell to it. Not really pleasant. The reason the skunk, when it sprays you or sprays something, it smells so bad, is because of the thiol group. The skunk emits these three molecules, and this in combination, all these three things in combination, makes that horrible smell. A little fun fact is that, if you did not know, the skunk sprays with its anal glands. Yes, from its butt. It usually has about, roughly, I believe it was like 7 sprays or 8 sprays every 10 days. So it can only spray something 7 times in 10 days. Because they need to regenerate these molecules. If you have acne, you may be prescribed this sulfur medication. It's like a sulfur wash you put in the shower. It smells not pleasant, not too nice. But actually is used to treat acne. Now we have the sulfide group. The sulfide group is basically identical to the thiol group, except we have replaced the H, the hydrogen, with an R group. So it's basically a sulfur bonded to 2 carbon atoms, or 2 whatever atoms you want it to be. That's not hydrogen. So here's an example. diethyl sulfide. Just like diethyl ether, this is diethyl sulfide. Instead of an oxygen, we have a sulfur atom. This is an amino acid methionine. Here's the sulfur group, the sulfide. Because this is the carbon right here, and this is the carbon right here. The start codon, you may have learned this in biology or molecular biochemistry, or whatever class. There's a start codon called AUG. AUG codes for this. And it's distinct because it has a sulfur group. Methionine has a sulfur group. Now, aromatic. Aromatic is basically a fancy way of saying a carbon in a ring, or carbons in a ring. So here's a carbon here, 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 and here. It's a ring. I think this might be the most interesting one out of all the amino acids in this video. This is called toluene. It's basically our ring, our carbon ring, and a methyl on the top. This is what's in Sharpies. Toluene is actually a sweet smell. Now, here's the thing. I don't want you to go smell Sharpies. Please don't. And there's a reason why. You may have heard this back in elementary school where people used to sniff glue or even Sharpies. Or even now, people do it now. This is why. It's because of toluene. Toluene, when inhaled, gives you that high effect. It kind of makes you drunk when sniffed or inhaled. However, when you actually inhale this, it actually can cause severe neurological consequences. It's not please do not do it. It's not good for you at all. So when people like sniff paint or inhale paint, it's the same thing. Toluene's in paint and in Sharpies. Like permanent marker. The reason this happens, why you get high, is because GABA is a depressant. It's your depressant neurotransmitter in your body. It calms everything down. Well, what you're doing is you're increasing this depressant molecule, and at the same time, there's something called MDA receptors. MDA receptors where glutamate combined. Glutamate is a positive excitatory neurotransmitter. Well, you're going to be inhibiting that excitatory transmitter. So in other words, you're going to be more depressed. So on top of already being depressed because of GABA, you're going to be even more depressed because you're lowering your glutamate levels. And if you're exposed to basically this recipe right here for a long period of time or in excess, it can cause neurological damage, brain damage. So this is why a lot of people who actually inhale Sharpie fumes or paint go to the hospital. They end up in the hospital. It's because of this. If you want to get drunk, just drink. Okay, just do it. I know I'm gonna become a doctor one day, and I'm gonna be a really amazing doctor. I'm gonna tell my patients, go drink. Don't sniff Sharpies. Go drink instead. I'm joking. Please, do not do this. But yes, this sums up the functional groups part 2 video. I will post a part 3 in the due time. But if you found this video helpful, please like and subscribe. Until next time, later.